Hi guys, today let's finish the infinity square root equation. In the last three video, we talk about infinity square a plus, infinity square a minus, and a plus, then a minus. And then today, our equation is minus first, and then plus second, which in turn go to infinity. So similarly, if we let the value of this number equals x, and then we start from the third square root. So we can see this part after here still has a limited minus plus go to infinity. So it is still x. Then the equation can be written as x equals square root a minus square root a plus x. Then if we let y equals square root a plus x, so we know x is greater than 0 and y is greater than 0. So this equation can be written as x equals square root a minus y, because this part is actually y. If we square both sides, we get x squared equals a minus y. And then if we square this equation out, it is y squared equals a plus x. If this is equation 1, this is equation 2, we use 1 minus 2, get x squared minus y squared equals a minus y minus a plus x, which equals negative x plus y. And the left side we can written as x plus y times x minus y. So for this equation, the two solution is either x plus y equals 0 or x minus y equals negative 1. So y equals negative x or y equals x plus 1. And then the only situation y equals negative x is they equal 0 together. So a equals 0, x equals 0, and y equals 0. And then if a is greater than 0, let's go to the second equation. So the first equation is square root a plus x equals negative x, which is x squared minus x minus a equals 0. Or here the second equation is square root a plus x equals x plus 1. So it is x squared plus x plus 1 minus a equals 0. So this equation also has two roots here. X1 equals negative 1 plus square root 4a minus 3 over 2. And x2 equals minus 1 minus square root 4a minus 3 over 2. Then we need to reject s2 because it is less than 0, obviously. So reject this one. And then if we check x1 is greater than 0, actually we can get a need to be greater than 1. So when a equals 1, a equals 0, we use the first equation. And then when a is greater than 1, we use the root x1. Then let's take a look at the coordinate plane. This is a and this is x. So the first equation here is going to look like like this, and then here is 1, here is 0. So when a equals 0, x equals 0. And then the second equation is going to look like this. And then here is 1. So we're going to use this part of the curve when a is greater than 1. Alright, after doing this, let's take a look at this example. So a equals 5 greater than 0, so the root is x1 equals -1 plus square root 17 over 2. Alright,